Hi everybody. We're going to be looking at clusters, gaps, peaks, and outliers next. First question is, which of the following are accurate descriptions of the distribution below? So let's take a look at the distribution. Snow days each year for Chalden Middle School. Okay, so the first thing that we should recognize is that, again, the majority of your data is to the left side, right, of this distribution. And we see that this is unimodal right here, right? There's one peak right there. It's unimodal. Okay, and then it quickly tails off. The data values tail off. We have a gap, and then we have one data value right here at 10. So from this we can say, okay, so definitely this looks like it's tailing off to the right. So this is a right-tailed or skewed right skewed. And there's a gap here, right, in the data from 6 to 10. There's a big gap. And then there's one value at 10. So this value, basically data values that seem to be apart from the rest of the data set, right? Apart from the rest of the data set, they are called outliers. Okay, so this one right here would be considered an outlier, right? An outlier. So basically outliers are data values that are apart from the rest of the data set or the distribution, and they are pretty far away. They're not close. So if there was one here at 7, that wouldn't be considered an outlier. There has to be a gap. There has to be a gap and then an outlier. All right? So then let's take a look at our choices here. We have, which of the following are accurate descriptions? Choose all that apply. The distribution has an outlier. Definitely. It's got an outlier to the right. Okay, so A is good, right? A would definitely be a choice. The distribution has a cluster from 7 to 9. Okay, so a cluster here, a cluster represents, a cluster is basically it's a bunch of data, right? It's like a little group of data, or data values grouped together, right? Data values grouped or bunched together, okay? They seem to be a little bunch, okay? Bunched together. All right. So it's like a little mound, if you want to call it a little mound, a little separate mound in the data set. So we have our main data set right here, right? This is like the main data set right here. And if we had a cluster, we would have a little mound here by itself, okay, with its own little peak, for instance. All right, here there's nothing, there's a gap, there is no cluster, so therefore B would not be the choice. And then none of the above, no. Okay, so let's pick our answer. Let's pick our A and check, and that is correct. Okay, let's try another one. Which of the following are accurate descriptions of the distribution below? So let's take a look. Okay, so this distribution, as you can see, number of guests by day at Seth's Sandwich Shop. Okay, it looks like even though we have a gap here from 0 to 39, starting from 40, right? 40 all the way up to 199, doesn't that look like a pretty nice distribution? A pretty symmetric distribution, correct? And as we turned before, this looks like if we were to connect the middle or connect the corners of each of these bins, we would get a nice bell shape, right? So this would be a bell-shaped curve right here, or a normal distribution, a normal curve. And definitely it seems like in this normal distribution, we have a unimodal, right? There's a unimodal distribution. From 100 to 119 seems to be the mode right here, right? So data in there. We have the most number of data from 100 to 119. Okay, so let's take a look at our choices. The distribution has an outlier. Well, definitely there are no data values that are apart, right? Very far from the main set of data. So that's not a very good choice. B, the distribution has a cluster from 0 to 39 guests. Well, this distribution had nothing. There's a gap from 0 to 39. So I guess our answer here is none of the above. Okay? Let's take a look at another one. There's quite a few actual problems. There's 7 problems in the set. Which of the following are accurate descriptions of the distribution below? So let's take a look. All right. So definitely here, it looks like, okay, it definitely does not look like this thing is symmetric, correct? It definitely looks like from, what is it, 33? So it looks like from 33, that looks like that's at 33. The minimum is at 33, and the maximum goes all the way to 49, correct? But up to 44, right? Up to 44, this looks like the majority of the data has been pushed up to the left side here, correct? It looks like it's sort of skewed left, right? It looks like it tails off to the left side. The majority of your data is up here for this set. And then we have a gap. And then we have a little cluster. Okay, this is what we mean by a cluster. A group of data that seems to be off by themselves that has their own little peak right there, right? So that's called a cluster. This is called a cluster. All right, and definitely we have a gap. There is a gap in this data. So let's take a look at our choices. A, the distribution has a peak at 41 years. Okay, definitely at 41, this looks like there is your peak, right? It is unimodal. Okay, that's the peak, right? Oh, actually, it's bimodal because we have a peak here, but we have a peak here too, right? So this is this 41 years old, right? There's the most number of data for that. Number of teachers at Quirk Prep. So we have the most number of 41-year-old teachers at this school. Okay, that is true. All right. Distribution has a cluster from 47 to 49. That's also true, right? So from 47 to 49, we have this little cluster right in here. All right. So I think we're good. Yep. Okay. Let's take a look at another one. Which of the following are accurate descriptions of the distribution below? Okay. So here, okay, as you can see, from 20, we have our main cluster, right? Main data set from 20 to 32. And even though we have 2 peaks, right? We have a bimodal distribution here. Actually, we have 3. We have these 2, and then we have this one, correct? So this is a trimodal distribution. Okay, but again, the main group seems to be here, although that's a pretty big group in itself. Again, this data represents gas mileage for each car at Miley's Motors, and this is a miles per gallon. Okay. Now, and then we have a gap here. There's a gap. So we've got this gap in here, right? And we've got peaks here and here and here. Okay, and this definitely looks like another cluster. Okay. So let's take a look at choices. The distribution has a cluster from 33 to 37. No, there's a gap. There's no cluster. There is a gap, right? So that doesn't look like, whoops, maybe I go like that, right? Okay. 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 So that definitely doesn't look correct, right? So this is wrong. We're gonna put an X on this. There's an X here. Okay, again, there's a gap, not a cluster. Distribution has a gap from 38 to 42. No, from 38 to 42, we have a cluster, not a gap. So that's wrong too. So I guess our correct answer is here, none of the above. Okay, so another one. Which of the following are accurate descriptions of the distribution below? Okay, so let's take a look. Whoa, look at that. There's a big gap in here, right in the middle of the distribution. Okay, so if I had to like kind of graph this thing, I would probably put like a, I don't know, put like a like a U type, maybe an inverted, right? Symmetric maybe? Yeah, there's a gap in here. And then we have two peaks in here. So this is bimodal, right? And they're separate. So we can't really even call either of them clusters because they look about the same, right? They look pretty even. Annika's score in Happy Bears by game. Okay, so let's take a look. The distribution has a gap from 30 to 60 points. Absolutely, that is correct. The distribution has a peak from 80 to 90. From 80 to 90, this is not a peak. That is incorrect. And then none of the above. Okay? Two more. Which of the following are accurate descriptions of the distribution below? Choose all that apply. So we have now a dot plot, right? And this looks pretty nice, doesn't it? High temperature each day in Edgeton, Iowa in July. So this looks pretty symmetric. It looks like a nice bell curve, right? If you were to kind of, again, draw a curve through this. Again, it's not perfect, but then again, most normal distributions are not perfect, right? It looks pretty even with 22 being your mode, right? So it is unimodal and it is symmetric, right? Roughly symmetric. So it's a normal distribution. Let's take a look. Distribution has an outlier. Well, you can't really call these outliers because, again, what do you need for an outlier? You need a nice big gap, correct? And there is no gap here. There's no outliers. The distribution has a peak at 22, definitely. All right, and that is it. Okay. Last one. Which of the following are accurate descriptions of the distribution below? So definitely this thing, right? It looks like there's an outlier here. There is a gap here. And then this thing looks like it is tailing off to the left. The majority of our data in this main cluster, right? In this cluster is to the right, which means it looks like it's tailing off. There's fewer data values on the left side of this distribution. So this looks like it's skewed left, right? And then we have our peak. We have our mode right here from 16 to 17. And test scores by student in Mrs. Frine's class. So distribution has a peak from 12 to 13. 12 to 13, that is not a peak. Distribution has an outlier, definitely, right? This one student here did pretty poorly, right? As compared to everyone else, we have a nice big gap here. And I think that's it. So let's check it. And that is correct. Okay, guys? Okay, take care.